now, at this exact moment, there is an object flying between the stars. It carries the sound of rain on a distant world, a melody by Bach, and the recorded heartbeat of a woman who had just fallen in love. Nobody sent it there. It just kept going. The year was 1977. The Beatles had been broken up for 7 years. The first Star Wars film had just hit theaters, and NASA launched 2 probes into the void, not with any expectation of hearing from them for long, but with a quiet hope that something, somewhere, might one day find what they carried. Voyager 2 launched first, August 20th. Voyager 1 followed 16 days later, on September 5th. But Voyager 1 took a faster route, threading through Jupiter and Saturn at higher speed. And by February 1998, it had overtaken its twin. Today, Voyager 1 is the most distant human-made object in existence, and it is still out there, still moving, still, impossibly, talking to us. This is the story of the loneliest thing we ever built. The mission was designed to exploit a rare planetary alignment, one that only occurs every 175 years, a gravitational slingshot. Each planet's gravity would accelerate the probe onward to the next, like a ball rolling down an invisible staircase through space. Voyager 1 flew past Jupiter in 1979, past Saturn in 1980, and then it kept going, north of the solar plane, gaining speed, aimed at nothing in particular except the dark. What it sent back changed everything we knew about the outer solar system. Io, Jupiter's moon, was actively volcanic. Saturn's rings were not solid sheets, but billions of individual particles. Europa held evidence of a liquid ocean beneath its ice. 5 billion bits of data, a mission that cost $865 million in total, roughly 8 cents per American per year. Some bargains are impossible to measure. But here's the part most people don't know about, the thing that makes Voyager more than a science mission, what it was carrying. Both Voyager probes carry an identical object, a copper disc plated in gold. On its cover, a diagram, a map made of pulsars so that any intelligence capable of receiving this could calculate exactly where our sun sits in the galaxy. It cannot be played on a normal turntable. It spins at 16 2/3 RPM, a speed chosen specifically for this recording. A committee led by Carl Sagan assembled what humanity would say to the universe if it had one chance. They chose 116 images, 27 pieces of music, Bach, Beethoven, Chuck Berry's Johnny B. Good, folk songs from Azerbaijan, panpipes from Peru, greetings spoken in 55 languages, and the sounds of Earth itself, ocean waves, wind, thunder, birds, and the low resonant calls of humpback whales. Messages from President Carter and UN Secretary General Kurt Waldheim were also included, but there is one layer on that record that almost nobody talks about. On June 3, 1977, 2 days after agreeing to marry Carl Sagan, a woman named Ann Druyan sat in a recording studio. She had electrodes attached to her head. For 1 hour, she let her thoughts run. She thought about the history of the world, about love, about what it meant to be human. Those brainwaves, her EEG, her heartbeat, compressed into roughly 1 minute of audio, are on the disc. Somewhere between the stars, a love story is traveling at 61,000 kilometers per hour. But before we get to where Voyager is now, and what it found at the edge of everything, we need to understand what it had to cross. Our sun does not stop at its surface. It breathes outward, constantly exhaling a stream of charged particles called the solar wind. That wind fills a vast invisible bubble around the solar system called the heliosphere. Everything inside it lives under the sun's influence. Everything outside is something else entirely. That boundary is called the Heliopause. And on August 25, 2012, Voyager 1 crossed it at approximately 122 astronomical units from the sun, meaning 122 times the distance from Earth to the sun. It became the first human object to enter interstellar space. Scientists confirmed the crossing on September 12, 2013, using data from Voyager's plasma wave instrument, detecting the sudden, dramatic shift in plasma density that can only occur in the space between stars. Published in Science, peer-reviewed, definitive. Voyager 2 followed 6 years later, crossing on November 5, 2018 at 119 AU, from a different angle. 2 crossing points, 2 independent data sets, the shape of the sun's bubble measured for the first time. We did not just detect the edge of our solar system, we sent something through it. Before Voyager 1 made its final crossing, Carl Sagan asked NASA to do something the agency considered pointless. He wanted the probe to turn its camera around, back toward home, and take a photograph. NASA resisted. There was no scientific value. The cameras were being powered down to save energy. It was, by any practical measure, a waste. Sagan pushed for years. On February 14, 1990, from roughly 6 billion kilometers away, about 47 astronomical units, Voyager 1 turned and looked back. The image it captured shows Earth as a point of light less than 1/10 of a pixel wide. That photograph became known as the pale blue dot. Sagan wrote, "A mote of dust suspended in a sunbeam. Every war ever fought, every leader who ever lived, every act of love or cruelty or invention, compressed into a pixel. That is what the loneliest object we ever built looked back at." As of mid-2026, Voyager 1 sits approximately 170 to 172 astronomical units from the Sun, advancing roughly 3.6 AU every year. The signal from its antenna takes more than 23 hours to reach us at the speed of light. By November of this year, Voyager 1 will be exactly 1 light day away, around 25.9 billion kilometers. The probe runs on a plutonium-238 radioisotope thermoelectric generator, a device that converts the heat of radioactive decay into electricity. Plutonium-238 has a half-life of 87.74 years. Each year, Voyager loses approximately 4 watts of power. It currently transmits on roughly 22 watts, less than a standard light bulb. On April 17, 2026, mission controllers turned off one of the last active instruments, the low-energy charge particle detector, to conserve what little power remains. 2 instruments remain online, 2 eyes still open, in the dark. Scientists estimate Voyager 1 could keep operating into the 2030s, with telemetry possibly receivable until around 2036. After that, silence. But after the silence, Voyager will not stop. It will just stop talking. Voyager 1 travels at approximately 17 kilometers per second, about 61,000 kilometers per hour. At that speed, reaching the nearest star system, Alpha Centauri, would take roughly 75,000 years. That is not Voyager's destination, but the number tells you something about the scale we are speaking about. Its actual closest stellar encounter, according to NASA, will be with Gliese 445, also known as AC Saturn 388, a dim red dwarf star currently about 17 light-years away, but moving toward us. In approximately 40,000 years, Voyager 1 will pass within 1.7 light-years of it. 40,000 years ago, human hands painted the caves at Lascaux. Our species has existed for roughly 300,000 years. Writing has only existed for 5,000. And somewhere in that incomprehensible forward stretch of time, a golden disk will drift past a star, still carrying rain and Bach and a heartbeat. The craft's structure may erode very slowly over millions to billions of years due to interstellar dust and cosmic rays. The golden record itself could survive for up to 1 billion years. We began with a question. What is that object flying between the stars, carrying rain and music and the brainwaves of someone in love? Now you know. But knowing the facts is not quite the same as grasping the feeling. Voyager 1 was not launched to survive forever. It was launched to look, to listen, to gather. And when its work was done, it simply did not stop. 49 years later, it is still transmitting, still crossing ground no human hand or eye has ever touched. The golden record was never really a message to aliens. It was a mirror, a decision made in 1977 about what humanity chose to say about itself when it thought no one was listening. If that probe is ever found, in 1,000,000 years or 1 billion, what it carries will say more about us than any monument we ever built. That is the map of forever.